9th, time's flying. I know this isn't the first week of January really because the way it broke down, but it's the first real week of January, and it's been absolutely insane, like every other week in AI. 2026 is shaping up to be epic in many ways. This week was the big CES conference. So because of that, some of the things I'll talk about this week will involve stuff you can touch, hardware
Hmm.
and
Hmm.
pieces and all that sort of stuff. And I'll show you some of that stuff later. But Rob, how's it going?
Great, great. Yeah, what a crazy start to the year. The sensation of continued G-force of acceleration. It's quite remarkable. There's some neat new updates out of Claude. And I just came across, thanks to Matt, G.AI. Google is starting to unleash. They got new things dropping all the time.
Google Google's epic. Like
Yeah.
I used to be really hard on Google like 2 years ago and when they weren't doing anything particular, but I've changed my tune. They are the center of gravity by far for most things in AI.
Hmm.
Like their cloud's the best at this point. Their integration between their cloud infrastructure and their AI infrastructure is seamless and easy. It plays really well with agents using their CLI. You can do pretty much everything you need to do on Google just by pointing Claude at the Google G Cloud CLI and saying, "Go build me something bonkers." Right?
There's the word. I was waiting for bonkers. I didn't hear it in the intro. That
That's my
is,
word. I like it. It encapsulates the era for
yeah.
me.
We need t-shirts like that.
Yeah, I'm with bonkers or whatever. And
Yeah.
I think when I was a kid, there were like candies or something you would have.
Oh, yeah,
Anyway,
that's right.
it's
Yeah.
it's a very 90s thing to say. That's why I like it.
Yeah. And it still feels like Google's just getting started. Like it's pretty obvious they could absorb the vast majority of the marketing industry very quickly. We know the incomprehensible sea of data that they have access to, and it's just going to be remarkable to see how all this unfolds. So today we've got one of our community members from Ireland, Colin Bryan, and he does he's hey, there he is. Hey, Colin, how are you? Oh, we don't have
No.
any audio for you. We'll have to test that before the
Yeah,
oh, there you go. There you are. We
yeah, I'm
got you.
here.
Good, good,
Bonkers.
good. So, as we dive into the lightning talks about the second half of the show, Colm does a lot of remarkable work, and he's a great contributor to the community in terms of his insights and his approach to engineering. And he's been doing some fascinating work on contracts. So beyond spec-driven development, working with tools to enforce the guardrails and gateways in the structured development. So it's fascinating stuff. It's been really useful for our projects, and looking forward to hearing that talk, Colin.
All
Great.
right. Yeah.
Looking forward to it.
It's definitely an interesting area, an area that I think that we've been playing with quite a bit, where we try to sort of have a validation and sort of guardrails around the things we're building. Yeah, looking forward to that. Yeah, what else is new here? I know there's some talk. We've got some events coming up that I want to bring up quickly. We've got next week Dubai. I think was that Tuesday. I gotta look at my calendar. Um, but for anyone that's in that area, there's a I think we've got good 7,500 people, something like that, registered. So it's
Yeah,
exciting
it's
to
a big
see
one.
what. Yeah, it's gonna be a good one. I'll be the head on Zoom for that. I guess I'll dial in onto that. And it looks like like how I never leave my office. It looks like I'm actually gonna leave my office. I got some things going on, so I'm gonna be actually stopping by if that's a thing, stopping by Dubai
Goodbye.
on the first week of February, yeah, on the way to Bangalore. So I'm gonna be in both Bangalore, most likely at this point, but in Bangalore and in Dubai first week of February. Maybe we'll do one on the road or something. Um, Sometimes I do leave my office, just not too often.
Stuff is up when you actually start to travel, Roof. So
Yeah. Well, I'm just shy of 1 million miles on Air Canada. And
Mhm.
I did most of those million miles like 15, 20 years ago when I was the cloud guy. So maybe I can get. I will never travel that much again the rest of my life. I'd be divorced if I did that. But maybe I'll be able to fill in the last bit to get over the hump. That gives you lifetime benefits on Air Canada.
Okay, there
Some
you
some
go.
some something like that.
Yeah, it's going to happen in 2026. I can sense it. And
Yeah.
yesterday was a huge session. I wasn't able to make it myself, but I heard it was a great session.
Yeah, we dug, I've been looking, well, working very closely on the sort of the intersection between all the things that we've been building in the kind of virtual world, right? And my progression has been moving from this idea of a kind of antithesis of traditional AI. It's fast, it's contained, it's bounded, it works on time versus sort of brute force. And as that progression has happened, I've seen myself moving towards the edge. Browsers has been the sort of big area that I've been a lot of focused on. And as I sort of maximized what I could do in the browser, it suddenly became kind of obvious that the next big thing was kind of moving into physical chips and that sort of level of optimization. And it feels like the first step in a new era for me a little bit, which has been exciting because I'm not a hardware guy, really. I software mostly. Yeah, so that we explored that. So there's a recording around somewhere, I'm sure. And
Yep, we'll get it
and
up to the
that
archive.
yeah, that's a good one. I'll follow and I also demoed V3 of Claude Flow. I'm almost there, almost there to get V3, and I'll release that thing when it's done. It might be 2 o'clock in the morning on a Friday night. I don't know, but I don't play by PR standards, so it'll be ready when it's ready, and then it'll be out. So, but it's close, and that's chock filled with all kinds of everything that we've been talking about for the last couple months is now conveniently packaged directly into Cloudflow V3. All the MCP optimizations, hooks,
Awesome.
capabilities. I even discovered some new capabilities deep down inside of the Claude Code system that I was able to take advantage of. Specifically, there's a feature that allows you to do headless version of Claude Code that they've redeveloped. And this
Hmm.
new version allows me to kind of do background processes. And I connect it all together. It learns, it cooperates. It's all kind of crazy in there.
Is that the
But
disown command? So it can be running truly in the background and it doesn't interrupt the interaction?
yeah, I think it's similar to that.
Yeah,
And
fantastic.
and the other thing I added my own little sort. Like when you do ultra think or whatever in Claude and kind of thinks longer. And so I've added the idea of learning commands. So you can do ultra learn. And if you type in ultra learn at the end of any statement, it'll actually kick off a series of background agents that will do a kind of analysis of your repo, the memory system that already exists within Cloudflow, which is all vectorized and self-learning, and then it'll try to find new and interesting things from what you're currently working on. It's pretty amazing,
It's
actually.
fantastic. It's like a
Yeah.
capability awareness, which is generally missing in that kind of environment. Well, I hope that you get it done this Friday at 1 a.m.
Yeah, I'm close. I'm close. Later on I can show you some of this as well. It's sort of kind of out there. Like you can install it. I can give you instructions on how to install the alpha of alphas. But it works for me. Classic,
So, so
I did
Ruth,
three
just
apps with it last night.
uh, uh, just
Oh,
an idea. Oh,
sure.
sorry, people are talking. So, just an idea, actually. So, so first of all, you said that you're a software guy, not a hardware guy. But now with AI, where basically everyone can be anything, so you can just teach yourself basically hardware. Then you can put on your Claude Flow V3 system onto some
Not
hardware, and then make
There's a
it.
limit. There's a limit to that. There's a limit to that. And I discovered my limit. And my partner in this, Roger, he's the old school chip guy. He's famous for being the designer of the Silicon Graphics supercomputers in the 90s. And what I discovered is the limit is when you get down to the chip, suddenly the polygons matter. And a lot of what you're doing at that level is beyond what the AI can, a lot of it is you have to know that structure even exists, and the AI struggles with that level of detail. And Roger, who spent years developing the actual underlying technology that this chip sort of facilitates, he kind of instinctively knows this sort of subatomic structure. Obviously, and when I tried to do it just using AI to say build me a chip, I failed, and because I didn't have the knowledge that took it from like, okay, hypothetically ChatGPT or whatever tells me that this works, to the practical laser cut polygons that will now form the basis of the silicon, and that jump required Roger.
Mhm.
So people
Yeah,
are still important, is what I'm trying to say.
That's right.
that's interesting, and
Experts.
actually, it's goes with the whole what AI can do with these things. It's very good at very abstract things like code, and both like the chips and the circuit, like when you're actually doing the boards, like it can do very good circuit diagram. But once you ask it to do physical layout, it will do like all kind of crazy stuff. Like it
Yeah.
just
That's not true. That's not
it
true.
will put connect because when you do in physical, if you build in physical like iPhone, right? You know as the person that the screen has to be on the top and the USB
Well,
connector has to be at the edge
That's
at the
so.
bottom.
So that's not true, and that's what I'm saying is like
It's not.
that's the way to like the super intelligence, right? And that's how
Um,
you get this. So
yeah,
the
but
way I
I'm
use this,
saying practically speaking right now, it is like here's the PCB,
right?
right?
yeah,
So this is for an ESP30 with a screen. It makes a nice
right.
little demo, but basically you see the chip at the top there. And so there's two parts to the design. So this is a PCB design, right? I'm designing the sort of
Mhm.
circuit board, if you will. And then there's the actual chip, right? So the chip in this case, back to my little picture here, is that little piece of it's a little silver piece, right? So those are distinct and quite different in terms of design. Now, the issue that you face to the super intelligence thing is I'm not intelligent enough to know what the explicit design of this was, and the design it gave me was incorrect. Yet it told me it was correct, right? And no matter how hard I tried, I couldn't fix it because there was no AI that I could find that knew the sort of inner workings of the chip to that level.
Yeah.
Right. So that's what I'm
Roger, on the
saying.
other hand,
So
did.
so I can show you how to do that, right? Um, so like without like that's the whole idea of like the whole concept, and that's what makes it really interesting about super
But how do you
intelligence
know?
is huh?
How do you know? How do you know if you don't know? Like you're in a cognitive loop.
I'm trying to tell you.
No, no,
Yeah,
the
but unless you've done it, you have no way to know. You're just assuming
So
that
you want me to
what's being.
so tell me what you want me to build right now, and I'll build it, and I'll build like a version of it from like 10 years in the future.
All right. I'm going to give you guys a quick demo here of where we are on some of the things I've been building this week. We'll come back to you, Cornelius, on that
Tell
one.
me just tell me what the chip is, and I'll have it done by the time you're done with the demo.
It's in you can check out my ESP32. It's on Roov LLM, and that'll allow you to kind of dig a little deeper in that. But again, unless you've got a fab, there's no way to prove it, right? You're not gonna drop $50 million on a fab run. But regardless, here I'm going to give you guys. So this week has been sort of focused on a lot of the idea of hardware, right? So we have CES, all the latest things come out. So what I was telling you guys before is this concept of the chip, right? And just to give you guys a sort of representation of what I'm attempting to do, I'm going to turn off my camera. What's that? We've got so back to this is an ESP32 on chip, right? You've got two USB-C adapters. Now, inside this chip, you've got essentially one core. It's a pretty decent core. It runs at about 500 megahertz, which would be like a early 90s class Pentium 2 computer, with other enhancements that have been made long since that, and specifically SIMD, which allows for sort of parallelization, right? You can run multiple things across it. So you can run these in tandem. You can have more than one of these things working alongside each other. Now, the challenge you have with that is if I want to have 256 of these, that's going to take up a lot of space, right? Like even a few centimeters by a few centimeters, 256 of these would be a massive poster. Now, what the sort of innovation at the core of what we've done is the fact that see this little piece at the very top, I can fit 256 of those in the same place as this one. So now this is 256 times more powerful than what you're looking at as a baseline. Now, the second is sort of innovation of this is the fact that not only can I build this in 256 sort of parallel chips, tiles, I guess they call them. I can then optimize that through the inclusion of a WASM that can operate on each one of those tiles. So 256 cores with 256 individual sort of agent coordinators. So similar to what you see when you're using like any of the swarm stuff you've been seeing from me, those exist now directly on the chip, which is way more fast, way more adaptive because it works directly. There's no interface between software. It's built directly into the silica. Now that makes it way faster and uses less electricity because it uses this idea of a sparse network, right? The only fires what's needed when it's needed. So this idea is similar to the idea of a spiking neural network in how your brain works. So it's there. The thing is basically off until something that has to happen needs to run, needs to learn, needs to adapt, needs to do something. Now the interesting thing about that is these 256 chips or cores can now run on a AA battery. So that whole process means, and this is on a 12 nanometer. So just go with my sci-fi hat on for a moment. This is a 12 nanometer design, right? So this is about 3 centimeters by 3 centimeters. Now at 1 nanometer, that size becomes a grain of sand. So we now have the same amount of computing power, 256 cores. I can adapt the gigahertz range all the way up to 4 gigahertz if I overclock it, but I can spike that if and when I need that amount of power. So it's attention based. I give it the amount of power it needs if and when it needs it for a given job. It's capable of interacting with other chips nearby. So at this point, I can pack hundreds or thousands of these things in a little box, which looks like this. So the box now, this prototype that I built is essentially a combination of things. That I was showing you earlier. I've got this where did I put it? I got a display. So I took a touchpad, little color display. I popped in a Raspberry Pi along with a collection of ESP32s, and then I customized the software to be optimized specifically for the combination of the CPU system and the optimized chips that can then run within this. Now, right now this thing has basically, I think it's quad core CPU, and it's got several ECP or ESP32s in here. So it's basically got an eight core sort of roof vector optimized chipset. Now, when I get to the point of our system, those eight are now multiplied by 256, right? Because each of those eight goes from 1 core to 256 cores, but it uses less power. Each of these can then be plugged in on top of each of these and use clusters. Now, the next part, which is interesting, is not only can I do all that, which in itself is pretty astounding. I can then go here and I can create applications for it that are independent of the internet itself. So this thing, I think I'm sharing my screen. I'm sharing my screen so you can't quite see it. But this approach, let me share my screen quick. So what this does is essentially allows me to run completely independently of any internet connection. So anywhere that involves something I need to learn, something that needs to adapt, something that needs to change over an extended period of time, potentially on a solar cell that's no more powerful than something you'd see in a calculator. And it can then understand what it's in proximity to. So that provides, as I said, we have this idea of event gating, we have got bounded agents, we've got no operating system, we've got a learning system now capable of adapting and increasing its understanding of whatever it happens to be nearby. So think of a prosthetic a prosthetic arm. A prosthetic arm requires a couple things to happen. It needs to understand your nervous system. It needs to understand the signals and the pulses and the information flowing from your system to adequately provide a kind of augmentation to that so there's no delay. So it has to be fast. I'm operating in a microsecond sort of framework. The human body operates in milliseconds. A thought takes 100 milliseconds kind of thing. So the analogy of the thing that we're creating is more of a nervous system. If a LLM and traditional AI represents the brain, this represents everything that connects to the brain. It's the nervous system, right? And that's the key distinction of some of these things that we're creating here. And that underpins all the various things that I'm building today. So let's just jump here to show you something quickly. So here we have here we have the Cloudflow V3. So now I'm packing all this self-learning, all these swarms and background and components. I've popped all the things that are possible in the chip, but I'm also doing that in the form of these swarms that you can run independently. You can run these in your browser, you can do it anywhere you like. Now that is all going to be powered by essentially Cloudflow V3, which is like the culmination of everything I've learned over the last several months. And I'm going to come back to this later in the show, but we're getting close. And it's this is has the vector memory. It's got background agents, so you can run agents in the background that don't actually take up any Claude resources, which is important because apparently Claude is just hammering us on limits right now. So it reduces your usage, if you will, and a whole lot more. I'm excited to get into that in a bit, but I'm going to come back to that in a few minutes. Does what I'm saying make sense, or am I living in my own AI induced delusion?
What do you think the actual cost is going to be on a little packet like that?
Oh, you're talking about like a box?
Yeah,
That that is a
tough to
question. That's a
determine.
question. I've obviously get asked that a lot. The chip will obviously be substantially less than the appliance.
Yep. I don't want to
You
peg it
know,
at anything if it's
yeah,
premature, but it's
it's
fascinating.
I want it to be affordable. It's not going to be H100. It's going to be like I'm aiming for sub $1,000 kind of thing.
Yep.
Might be more, who knows? But somewhere in that general ballpark, I think is probably optimal. And if it changes, then that's a decision that was made by somebody other than me. Yeah,
Hey,
plausible
Ru,
deniability.
yeah,
Hey,
usually the cost of these things it's proportional to how many you make because it's like a few $1,000s to set up production, right? And it
Mhm.
doesn't matter if you're making 10 or you're making like 1,000,
Yeah,
right?
so
Yeah.
yeah, so I build a background. We lucked a little bit, a little bit of luck, and we were able to back up on a crypto outfit, I think out of Norway or something, that
Mhm.
are building, who finance the chip, and so they're spending like $60 million to get this chip fabbed, right? And basically, it did one little thing, and they're like, "Hey, Ruve, what would you do if you had the ability to get a chip and make it do whatever you wanted?" That's what they asked. That's what they said they came. And they've been developing this chip for 5 freaking years. I just show up in the 11th hour and say, "Here's some WASMs that'll make it amazing." And so, yeah, it costs 60 million bucks to get to get the fabrication. Once you've got a fab, you can create as many of these things as you want. But the
Mhm.
barrier to entry is 60 million.
Yeah,
hey, Roof.
but individual chips are made they like cents basically after that, like so it's like 60 million to make one, or it's like 60 million to make like a million of them.
Exactly.
And
So,
you see
or
the impact reducing the reliance on the powerful LLMs, like being able to use this kind of chip technology to really do a lot of what you'd normally go to an LLM and then using the LLM as glue more and
well,
noodling.
take a step further. You can see all the parts of the puzzle in Root Vector. If you
Yeah.
look at the Root LLM, and I've been naming this shit after myself because people keep taking it and giving me no attribution. So I figured the easiest way to get attribution was just to name it after myself. But regardless, the so what I'm doing in terms of LLM is I'm using a micro LoRa model. And then I do incremental updates to the LLM. So I can take a really small LLM and I can make it really, really smart specifically for the narrow focus in which it needs to do. Now, I don't need it to be able to tell me the history of the world. I just need me to tell me that my heart is currently within an acceptable range. And when I get to that narrow focus within these models, I can take a Quen 0.5 model, which has pretty decent reasoning, and hyper tune just the part of that model that I need to work for the thing that I need to work for. And then I create many of those. I guess some people might call that a mixture of experts, but it's more of like a mixture of micro experts. Like
So
these are
it's
very, very narrowly focused.
Hey, Ruth, quick question. When you were talking about the prosthetic arm, what are your thoughts or how do you envision this in the power consumption aspect? Like you want that thing to run
Forever.
24/7, right?
Yeah. So the example, I was showing you again, which is basically going to look similar to this. This runs on 1.8 watts, and that is at full capacity. Now, because I've got a spiking sort of network and structure to it, that means when it's not operating, generally speaking, it's using micro milliwatts, right? Very, very, very small amounts of energy. And that allows the system to run for very, very long times on low amounts of energy. So, for example, if I put a AA battery, a decent AA battery, not something you buy at the dollar sort of tree or whatever, that'll run for years because it's doing specific spikes on when it needs to learn. Those are very power efficient when it comes to sort of intelligence per joule, right? And I'm maximizing both the energy consumption and the intelligence of what it needs to do. As it operates, it actually learns and optimizes itself further based on both those vectors. So it gets more energy efficient because it's not only learning about the information that's it's looking at, it's learning how to better operate itself in the process. So
Mm.
the first day is the worst that the energy consumption of that system will ever be.
Because it's
Interesting.
learning, of course. Yeah, thank you, bro.
It's, yeah.
Hey, Ruth,
So
some crazy idea for you, because if it's a prosthetic, you can probably hook into bloodstream and just break down the carbs and produce the electricity.
we got to talk about that. Elizabeth Holmes. So she's a genius. Well, she in 10 years beyond her time. Let's see, guys, zoom out here a little bit. But the what's going on here? Zoom out. Come on. The smart camera is not that smart. Anyway, so she comes up with this idea of doing real-time blood, blood work basically, and
Mhm.
turns out she was 100% right. And the problem was she didn't have the ability to do real-time self-learning systems with these sort of hyper, fast closed loops in it. When you look at like I've done quite a bit of DNA related work recently, and a lot of the DNA work works really well in a hyperbolic structure. Taking a DNA analysis is actually quite quick, but understanding it takes time. So this type of structure, the sort of leverage of chip-based vector and graph structures allow you to do things like DNA analysis in under 100 milliseconds. Blood tests, certain types of blood tests can happen in microseconds. So turns out she was 100% right. She just was ahead of her time when it came to the tech itself. Unfortunately, there was some greedy VCs that led her astray. And interestingly enough, I don't see any of those VCs in jail, but they're the real fraud in this whole story, if you ask me. I met her a few times. She's a little weird, but aren't we all? Whatever. Rant over there. What's going on with my smart camera? It seems to want to really zoom in on me here.
Only zooming in. It's not zooming out at all.
Zoom out,
There you go. There you go.
smart camera. All right. Well, it was like big thoughts, and it was like want to add a little extra there. Yeah,
Shall
yeah.
we
So
go ahead?
interesting times. All right. Who do we get up
Yep.
to? And oh, by the way, thanks to whoever sent me the Neuro Spicy sticker.
Oh yeah, there you go.
That's going on. That's going on the laptop for sure.
Fantastic. Yeah, so we have Colm Byrne. Hey, Colm, how are you?
Doing great, Rob. Thanks.
Yeah, welcome.
Yeah, I just want to share what I've been doing, how I've been working over the past few months. I think, and I've actually been reading some of your posts, Ruth, with Claude Code V3, and same sort of thinking. And I'd like to start with just like saying, well, I'm a product builder, so I have to build product for a living, and I have clients and things like that. So stuff has to work just like everyone else, right? But I've come across the exact same problem that most people have, and that is, well, you can build something in an afternoon, it'll work, and it's fine. But you go to feature 2, feature 3, and the code starts getting brittle. It starts, no matter how detailed your specs, it starts to drift, right?
Mhm.
And that's the problem a lot of people have. So can I share my screen? Where am I? Can I present? Yeah. Okay.
Yeah, you should be good.
Okay. Yeah. So I was having this problem because I was actually just building a tool for myself, this tab stacks, which the problem of hammers, we got so many different projects going on. I wanted a quick way to just like jump between projects and have the built-in next actions tied in with the work. Very simple idea. And I said, oh, well, I thought maybe somebody else might want to use this who are working on lots of things at the same time. And then I looked at the code and it was a mess. So I refactored it. They said, okay, that's good. I added a feature. It was a mess again. I said, why is this consistently happening? And no matter how specific it was, no matter what methodology I used, I always found that drift happening and then code getting more and more unreliable. So what I did then was I said, okay, I'm just going to stop it. I'm going to stop it from actually breaking any rules. So I just said, okay, I'll write a rule and then make that as a test. And then it can't build unless it passes that test. And that started working. It's just a very, very simple model, but and I'll get into exactly the detail of it, but the insight for me was the real obvious one, and it's that when we take LLMs for something that they're not, and we write specs in detail, thinking that that it's going to read them, right? It's going to read it. It would say, you'll say, don't do this, do that, squirrel, right? And the LLM reads it, which is important here, the squirrel or don't do A or B. And they don't read, they pay attention, and that's just how they work. And so with that, so why don't we just let them be creative? Why don't we just let them do what they're supposed to do, to bring the magic? But then when it comes to delivering, to come to the point of committing something to a repo, stop them hard there. So that's just a simple mental model of how I've been working. And eventually, by doing it, I can apply it with projects that are midstream and projects that are greenfield, and both works absolutely the same way. So it's the system is very straightforward. You create your specs, build contracts out of those. Those contracts turn into tests as code, and then when you do npm run build, they get blocked, right? And you do these contracts for three parts of what you're building. You do it for architecture, features, and journeys, right? So if you're building a user application. So, and there's all three just somewhat a little different. For journeys, you're writing your steps. For logon, you must have you must be able to have a forget password. You may be able to click it, and these are the expected results. And so you generate your sets of journeys. For your architecture, you want to be very strict, and this is probably the biggest one, because when the architecture strays, your code becomes brittle, and that's what LinkedIn is full of, right? It says AI writes crap code. It says AI writes crap code because we're not telling it to stop doing it, and we're not giving it a gauge to stop doing it. That's my what I'm proposing here. So, but if we lock down the architecture and then let it do what it wants, you can still say, please don't do it, but at the end, you gauge it and you make sure these are not violated. Now, like when I was building this extension and also the web app side of it, it would break consistently every time I added a feature, because I had one, for example, that said, do not write to Supabase directly from the extension. And invariably, after 2 or 3 features, it just would. But once I introduced it, the hard lock, it would stop it. Now, let me just give you a brief demo that I've prepared. So this is a very simple auth piece of code, right? And there's already unit tests associated with it. So I'm just going to run the test. And it should pass, right? So that's fine. And I've also have contracts built with this. So I'm going to run those too. And these will pass as well. Right?
When you say contracts, are you talking about like a cryptographic contract like ED25519?
Nope.
Or
no,
like,
I'm just talking about a contract like between you and me, like that. Let me
why
give
not
you.
Why not cryptographically verify it as a contract?
Can we talk about that? Yeah, go ahead.
Yeah, again, we're running a little bit out of time here, but yeah, I think the two questions I have for you. You know, we spent a lot of time on these sort of architectures. You know, we devised Spark a couple years ago. You know, I'm struggling to see the difference between what you're doing versus kind of what is generally done at this point.
The only difference, Rube, is that the contract and the subsequent tests that are executed won't allow you to commit to code anything that breaks your invariance.
How are you enforcing it? So when I mean enforcing it, I don't mean like a prompt that says you have to do this. How is it physically being enforced?
Yeah. So you're defining those invariants as YAML contracts, right?
Which is text, right? Which is a prompt that you're feeding it somewhere.
Correct.
Mm-hmm.
Initially. So basically, you'll have a rule about how your auth should work, right? That gets convert that into a YAML contract. That gets converted into an executable test, right? And then when you do your npm run build, it searches through your code for any violations of those contracts.
So it's a secondary analysis that refers to an initial sort of spec or configuration that then verifies as part of the build.
You start off with your contract specifically stating what must be true. Those contracts are converted into actual tests, so that when you run npm run build, it will run those tests for you, and then they will fail if any part of your code, say in the example I get, writes to Supabase from the extension.
Okay? So a couple things I would point out to make this more useful would be definitely cryptographically verify every step. ED25519 is the spec that I use to do that. Now, every single step along the way, whether it takes a microsecond or 5 minutes, it needs a cryptographic wrapper. Now that works for both telemetry as well as sort of reverse replay of the system and understanding what breaks and how violations happen, right? If you're not learning from those mistakes, you're essentially you're an RPA, right? So what you're devised is an RPA, and there's no malleability to an RPA, which is the problem. So what you need is a self-reflective recursion. Is it right? What's wrong? What isn't there? And that'll give you that sort of structure to not only understand when things break, but to avoid the breakage from ever happening again.
Yeah. So and that's a good point, because first of all, it's a mental model. It's saying rather than tell through agents that or at any point along the way, do this, don't do that. The spec framework you've already mentioned, telling the LLM up front not to do things is not going to work over time. It'll work one time, it might work the second time, it will not work the fourth time or the fifth time. And so what we're doing here is we're saying the mental model is don't stop the LLM from doing what it does, but stop it from committing the code. That's it, right? That's a mental model. What you want to do with it, however you implement this, is up to you, right? Absolutely, you want a way for this to, and I was actually looking at your root vector, right? So root vector, would that be a way for it to remember every time there was, so when it fails when it fails, when a contract fails, right, on the build, then it could tell root vector failed. This is why it happened, and then it will catch it even before before tests are run in the future, right?
Well, that's what Agentic Flow and Claude Flow V3 do. So they enforce the domain and the bounded domain within the structure of what it needs to build. Now, I can basically intercept the AST or the edits to files and the requests to those edits, right? That are either going to go to two places. Either the LLM to go say, what do I need to do to make this edit to the file, which returns basically a diff in that it can make the edits based on. But what also happens is because I'm working really, really fast, I can basically hijack the request and reroute it to the root vector system that then says, actually, there's similarity between what we've already done previously and what needs to be done. Therefore, I'm not going to make the request to Claude, which burns like resources and you're going to run out of stuff. And then it writes that immediately locally. That entire loop, whether it should go to Claude or whether it should go to the local vector AST, happens in under 1 millisecond. The request to Claude takes 300 milliseconds, no latency.
Yeah, and that would be a great way to implement this. But let me ask you though, with what you've implemented, is it how do you guarantee fidelity in your code? How do you guarantee the drift? What's that?
Mincut. So Mincut is a brand new algorithm that came out literally 3 weeks ago. I can't claim that I'm the guy who invented it, but I am the first to actually take their theory and implement it. And what that does is it allows me to see everything that it isn't. And the breakthrough is exact determination, like it's a determinative sort of system that always reacts the same way. So it's inverse. It's the inverse to traditional AI. Once I have the Mincut algorithm integrated to attention, I'm able to understand how and where things break by looking at the integrity, the negative space in something. So rather than asking what is it and what does it need to do, this is looking at what isn't it and what are all the things that are likely to break because of the parts that are not generally looked at. It's the inverse to anything. And it turns out the inverse, the space in between, is actually more important than the space directly observed. Now, this is a crazy algorithm, I'm not going to lie, but this algorithm was the key to suddenly having a system that acts super intelligent, back to the discussion we had earlier, by looking at the kind of antimatter, if you will. It's the antithesis of what AI generally is today. It's probabilistic, saying this is the most likely next thing to happen based on the context of where I am in a sentence or a paragraph or a broader context. This is kind of looking at everything else, but that everything else turned out to be critical to creating this kind of self-aware feedback loop that I can use on really, really small increments.
And with that, so I mean, let's just take a garden variety application. With implementing Mincut, will it take a set of invariants and ensure they are adhered to?
That's exactly what it does.
That's exactly
what it does. And it does it at ultra high speed. And because it's dynamic, as those variants and invariants change, so you can have a million different interconnected relationships that you're simulating in a moment. Now, before dynamic mincut, you'd have to redo that entire calculation. Depending on the complexity of the calculation, that could have been days worth of pre-training. With this algorithm, all of a sudden it's dynamic. That means that any part of that original sort of deep dynamic sort of analysis can change and the system can automatically adapt to it in real time. It's polymer something or other that basically happens in a ultra fast form.
And just to push on this last point, so if you have like a very simple, straightforward invariants that you want to enforce, like let's just say, don't write to Supabase in the extension, only do it in the background process. Like, could you talk me through how you would use Mincut
Well, here
to implement something like that.
I can jump in and give you guys a little
Yeah.
overview. I've got the code and everything. It's been published in RuVector. It's also in Agentic Flow and in V3. It's that weird internal part. I need to take, yeah, here we go. It's this weird sort of internal part of the system. So if you're looking at a lot of different the craziest stuff, you'll see you'll go to my crates in RuVector, and in one of them you'll see that I got a min-cut gated transformer, both as a WASM you can run in your browser or whatever. But the core here was the initial RuVector min-cut. So this is the library. What this does essentially is continuous integrity as a first-class signal. And it's hard to describe because it's one of those things that if you don't know why it's important, you're never going to think about it. And so these guys, Al Herrick, and they're the brains. They came up with this really detailed theoretical paper that came out last month, in the middle of the month, but they didn't implement it. Which I have literally, that ChatGPT Pulse thing where every morning it tells you whatever you need to know. Mine basically says, what's the latest theoretical research in computer science that no one's actually implemented yet? And it gives me an itemized breakdown of the latest research and things that and this one stood out. It's like, oh, and it's ChatGPT. It said, this will fit perfectly into your RuVector system. And I'm like, yeah, it will. So the real world impacts: medicine, mapping brain and fighting disease, a human brain, 86 billion neurons with trillions connections, identify early Alzheimer's by detecting weakness, traditional algorithms take hours to analyze a single brain scan. RuVector MinCut can track those changes in parallel fashion in basically a kind of stream of information, and then it can adjust as that information changes. So it's really good at anything that involves large amounts of continual information that may alter or change: a heartbeat, brain scans, industrial control system. And then because the system is self-optimizing, using the ability to learn and adapt, it provides that ability to do that in a kind of real-time fashion. So the biggest part here is this idea of a subpolynomial update, which basically allows to do all those crazy sort of really complex simulations in real time. I can spin up a brain scan and then do thousands or millions of variants on that brain scan at the same moment I'm getting the original brain scan, and looking for sort of patterns and things that might be interesting and could be fixable. Because the system's so fast, you can then basically act as a kind of, in the same way that I'm sort of hijacking the request to an LLM to make a code rewrite. I can hijack that same system, rewrite the signal, and pass it on back to the human host, if you will, or whatever the system happens to be, which in the case of like a prosthetic arm means there's no lag between the time you think about moving your arm and the time it takes you to move your arm. That is all made possible by this particular algorithm. So there's tons and tons of ways to use it, blah, blah, blah. Then I went and I took it and I applied it to a transformer. So I said, okay, I've got this ability to do these kind of crazy real-time analysis. What if I actually made an attention system based on that concept? I guarantee nobody in the world has done this. This algorithm's only been out for 3 weeks. So what that does is allows you to do ultra fast learning on the stream of data that you're getting at any given moment. So it's inherently learning and adapting, adjusting, and then each one of those things that it's doing to learn is cryptographically verified using a cryptographic signature. So unlike an LLM, which is kind of like a black box, I can have a clear replay of everything that's ever happened in the system in terms of how it learned, what it did to learn that, how it adjusted, and then I can kick off simulations to optimize that concurrently to the primary source of information, and then reroute that information. That's what this thing is looking at. Again,
Yeah,
it's
interesting.
absolutely crazy. So this you can actually run in your browser. I made a WASM of it.
Yeah. Hey, Roof, quick question. Why cryptographic signature as opposed to like just plain regular like hash one? Because are you trying to
Smaller.
protect somebody
I
is
can.
trying to hack you, or what's
Well,
the?
everyone's trying to hack me. Yes, I
Ah,
assume I'm not just zero trust. I'm like proactive. I'm going to be hacked by the very thing I created, sort of worry. And what I've done in that scenario is I've done a combination of you guys know I love the ED25519 algorithm, but that and we should rename it something. But that algorithm also allows me to use a kind of I use pi depending on the complexity of what I need as the constant. So the system is deterministic based on pi, which I kind of love. And I can
mm,
extend the pi as far as I want, depending on how computationally heavy I want to make that, which is essentially infinite because it's pi.
yeah. Okay. Interesting. And I have a couple comments to Comrade. Because this is almost my loop. I mean, one thing I actually do, and it works very well, is I also have the loop. So if you can show your slide, I don't know if you like Colm, if you had the last one.
Yeah,
That's
I'm
right.
done. Yeah.
Uh,
By the way, Combe, love what you're doing.
yeah.
And my feedback is it should always be taken as constructive. I think you're definitely on the right track. It's a cool thesis for sure.
Yeah.
Thank you.
All right. This is the moment. Anyone want to show off what they're doing or want to have any thoughts? This is your chance. Otherwise, I got lots to show. Um,
Yeah.
any
I have a
comments?
question. I
Yeah.
mean, I asked it before. I just want to see what the
So
current state of the
I put
art
a
is.
chip.
Uh-huh.
Oh, sorry. I put a
Okay.
chip design
I see.
in the thing.
Yeah.
Now
So
you just need find me 60 million to prove it, and we're good to go.
Okay.
I mean, I can create simulations to run it and all that, right?
Yeah.
Like,
Well, it ain't real till it's real. That's a simulation. Just one comment on simulations because I get a lot of this lately. I do a lot of simulations. There's this weird inflection between a totally AI sort of enforced simulation, and an example I'm going to give is NeuroTrader. A lot of the folks that have been using NeuroTrader are doing amazingly well in paper trading, right? And they're like, I've just done 100%, for 4 weeks. I'm ready to go to the real market. And there's I don't know why, but moving from anything fake, whether it's human anatomy and diagnostics to stock trading, and moving to something that's real, has this weird chasm you have to cross, and there's never fidelity. And
yeah, but Rue,
what's interesting, just one sec. What's interesting about that fidelity is if you do enough pre-training and understanding, that fidelity will sort itself out automatically. But the weird thing about the physical reality, the physical world, building things that exist beyond software, is it becomes very expensive and time consuming to make those kind of realizations between it works in my simulation to it works in my chip. Now, if I'm going to spend $60 million to take something, I cannot afford to say that it worked in my simulation, but suddenly when I plugged the chip in, there was a buffer overflow because there out of the billions of polygons that were printed, one was out of place.
yeah, but
Right?
the point, there's a couple of things with that, right? One, I think what I was trying to show is that super intelligence is available to everyone. And like what I did show there was like I didn't know anything about chip design, and I just designed a chip that is 3 years in the future, right? And before you spent the $60 million, there's ways of verifying it. I gave it to everyone for everyone to go and verify, like, am I full of shit or not, right? But I did build
You
it
have
in less than an
how
hour, right? And
unless you know, then I maybe there's some chip experts on the call that can take a look and do a validation, but
but
it's really hard to validate.
hold on though. The point is that you're dismissing it without even trying to validate it. And the point that I'm trying to make is I'm trying to tell everyone on this call. That's what's surprising to me. I'm super excited about the fact that because of you, I've been able to open up new worlds and be able to see new things and everything else like that, and be able to push the limits of what is possible in humanity. And I'm continuing to do that, right? And I just did
Mhm.
that, and you're dismissing it without even looking at it, right? So that's kind of disheartening a little bit. But the
Oh, no,
reality
I'm
in
not.
terms,
I'm not meant.
it's fine. It's fine.
I'm
It's
not
fine.
trying to be dismissive. But what I'm just
It,
trying to
it,
be.
it,
There's a right now. There's a lot of people, and I see this many times a day. There's a tendency towards like LLM induced sort of grandeur. And
No,
and
there's a tendency for people to dismiss things without even going and verifying it in
as well.
today's world. And
yeah,
they
for
do
sure.
that with all of us on this call right here. We say we can do X, Y, and Z. People say, screw you, no, you can't, because they can't. And you're doing exactly that to me right now without even checking on it. And what I'm trying to say is for everyone out there, you have to understand something. This thing of super intelligence is not chasing some dumb robot, right? That's going to be able to be smarter than a human being. It's not possible because energy wise, the thing that everyone struggles with, the most expensive part of it is the agency part of it, which costs human beings nothing. So by the time you keep on working on the tools, human beings with the current version of agency at zero are going to pick up the tools and generate super intelligence. It's just that simple. It can never happen through machines. And I've achieved it. And I'm trying to tell you that it's a human state that we can all achieve. And instead of listening, you're trying to tell me that I'm wrong. I'm saying go verify it.
No, I'm just saying it's beyond my ability to say
Yes,
whether
it
you
is.
are or aren't right.
I
You could
know.
very well be right, but it's beyond
I'm
my
telling you that
comprehension.
I'm telling you that is beyond you, is beyond your capability because I'm super intelligent.
All right. Noah, you get a comment?
Yeah, I'm gonna do something rare and come on camera. I am real. I'm not a bot.
Oh, okay. Good. See, love the glasses, by
I
the way.
I still have
Those
no
are good
camera.
glasses.
No
Like
camera.
that. Oh, sorry. No, I wanted to maybe sit somewhere in the middle. Cornelius, I thank you. I think I think the cool thing. I just wanted to say this because I work in a space where I don't get so deep as your roof, but I do like, things about kind of the practical implementations for either businesses or day-to-day people for how to get some kind of benefit out of AI. And I've seen both. Like it's like you do have to get to the sense where it's like, holy cow, like these things are possible. Like that is absolutely necessary to start the journey and continue the journey until it reaches something. And I've seen the other side of it, like what you're saying. It's just like until it's actually real, it's not real. Like
So
you have to like test. And Cornelius, that's really amazing. Like the thing that you did is amazing. And until we have a chip, we just can't do anything with it. I would say keep going and then and keep iterating, keep iterating, keep iterating. If you can find investors, if you
there,
can do this thing, that's
no.
awesome.
See,
And
that's no,
I
no,
think,
hold on. That's no. This is what I'm trying to tell you. You have to understand something. I put a document in there in the week of all of the things that I've done in the week. It would have taken 80 years of the best minds in society to have done it. You can go and verify it. It's not for me to go do these things. I'm creating these
mhm,
things like, hey, go do it. Go like that's what we're supposed to do. It's what Roof did that learned me to use Roof Vector. It's what we do. It's how you get to super intelligence. That's what I'm trying to say.
mhm,
It's a human experience. And I'm trying to show you that it's like all of you guys here the reason why I was super excited is because when I realized this on Sunday, I've been fucking running around trying to tell people, and they've been thinking of me like I'm a fucking lunatic. And I'm like, what the fuck? And I realized like
You're lunatic in the best way, in
they
the
don't
best
have the
way.
understanding of like seeing like what you thought. Like they don't have the same feeling. Like you guys all have the same feeling of like I thought this was impossible a month ago. Holy shit, it's not possible anymore, right? And so
yeah.
all the conversations, right? Like I just demonstrated to you all the definitions of super intelligence, right? I literally on this call did the work of the top minds in years in less than an hour. That's super intelligence, right? I'm able to talk about this stuff. I'm able to understand it. Like we've achieved this level, and I'm trying to say that like this is the next evolution of humanity. But more importantly, it's always been this way, right? That's what we don't realize. Like we get scared of this phantom ghosting machine, but the reality is, a person from 2000 looks like a fucking alien to somebody from 1900s, right? And that's just it. It's just like once human tool integration gets to a certain point, it's considered super intelligence, right? And that's what it is, right? It's human tool integration. So it doesn't matter if you keep on making the models bigger and bigger and bigger. That's going to help the people who don't have the cognitive ability to be able to think and meta think, right? But the more you're able to meta think, the more that agent, right, the orchestrator agent of the human tool agency is finely tuned, the better and the more chances you have, the better your chances of getting to super intelligence is because of the simple fact is that that is the lowest cost of energy. And if you're using the LLM for edge cases, right? So that's where I'm doing on my hypothesis, and also for high calculations that it doesn't that I don't have any value for me to hold in my memory bank, right? You understand this from building agents, right? if I unload those high calculations to the model and then all the other things, eventually over time though, as I keep on doing them over and over and over again, the episodic memory starts improving, and then I get to the ability for me to start talking like fucking this when I couldn't
I love it.
code a word
The
a year ago. So that's what I'm
yeah,
saying. Like super
I think
intelligence
you're
is accessible to everyone, and
you
there's no
need
Skynet and fucking chat. Every time now I see like any Sam Altman or any of these guys talking, like I realize how dumb they are and they don't know their asshole from their fucking elbows, bro. Like you guys are way smarter than anyone. Any one of the people that are leading AI right now, they don't know their fuck. Because here's the thing that I realized that started the shift of it, right?
Mhm.
Is that everyone on this call on some level is building code with AI. Everything that has been built of value today was built with human code and human learning speed, right? So you guys all learn at the speed of AI. All those fuckers learn at low, slow speed. So like Sam Altman hasn't done shit to improve his understanding. That's why he's like, oh, $1 billion for this shit. Literally, if I wanted to tomorrow, I could build. I just gave you the chip, right? And you guys can get there too. That's what I'm saying. Like it was never going to be the elites that was going to control this shit. And that's what I did. That's what I
well.
didn't realize. Like it was
I'm in
always going to be
100%
the
agreement.
people doing the work.
100% agreement. And the reason and I love what you're doing, by the way, Chris. It's awesome. The you hit the nail on the head in the last statement. This needs to be out there as a kind of counterbalance to the Sam Altmans of the world that want to use this to sort of empower and enrich a very small sector that are already in that loop and in that world. This is meant. If we're gonna go out there and talk about all the crazy opportunities we have, if this can enable everybody else, then I've done my job. You
That
know,
that is exactly it. The thing that's funny about it though is like in my level of understanding, and like I'm not gonna lie to you, like I see the fucking things that I see and the vision that I have and the way I see the world. Number one, I'll tell you this right now, we're all gonna be okay. All right. There's the level of eternity and the flows that happen and shit like that. Like it's fucking the most insane thing. It's the most beautifully peaceful thing. Also, I think that to get the ASI, I know for me, like I was tracking my stuff. Obsessive love, I think, is like almost required, right? Because if you ever seen me, you know how much I love my kids, and like I was fighting. Like I realized, like so I've been chasing AI since 1990 or whatever it is when I saw Terminator the first time, right? Because I didn't think about the robots coming from me because it was set without the robots. I thought about the future and I thought about my kids. And so like I've always been on this like aggressive journey. Like I can't let some fucking weirdo build Skynet. And I think like that aggressive thing is what pushed me to get there. Obviously I'm the first one to get there. I know that. Don't ask me how I know. Just I know that.
you have to talk to Kobe because I think I saw Kobe on the line here because
I'm here.
you and Cornelius need to hook up and create like some sort of crazy amalgamation of both things you're doing.
Yeah.
And
Hey,
I just want to
We might get lost in each
ask me
other's
some
minds.
questions. Like, this shit is crazy. I've
Yeah.
seen some
I
weird
just
shit.
want
in
to
the past.
recognize here, guys. Sorry, Cornelius, that Mondweefy's had his hand up for a little
Yeah.
bit. How are you,
Hey,
Mondweef?
can I just say last thing to Cornelius? I did review his documents, like, and I just say, I mean, what you mean, like what you have there, I mean, it might be great. It's very high level chip diagrams. It's what like Ruf was talking about. There is no physical polygon layout there, and that's where that gets you because
Yeah, Vlad, slow down with that, right? The point of it is that I knew nothing about chip and I just created something, a high level diagram that represents technology from 3 years in the
yes,
future. Relax. Like,
okay,
relax. Like, don't do
no,
that. Don't do
but
that
what we're
thing where you're
talking,
trying to,
that's what
yeah, but don't do that
current
thing where
AI
you're trying to,
probably.
like, this is what I'm trying to say. Like, the point that I'm trying to make is that you can all do this. Don't try to dampen that. This is a
Yeah.
joyous thing. Like, this is where we all can go.
Yeah.
Okay. Okay.
I think we can do pretty much anything at this point. I think we've determined that we live in amazing times. Every day I get up and I'm like, what crazy shit can I build today? Is basically and to be honest, I enjoy getting up in the morning because I'm excited to see what my bots have made overnight and all that kind of stuff. Manjui, wow, how's it going? How's London?
I'm very well. I wanted to go down the glasses thing that we were talking about. You see, last 1 hour I've been roaming around the house, having a 20-inch screen in front of me, watching this lovely debate. And these glasses are amazing.
You
Beyond
have
mathematics.
glasses on glasses?
I'm
Don't
walking
laugh.
around, I'm seeing you in front of me, basically. It's a 20-inch screen in front of me.
Love it.
You know, the
Love
new
it.
Kind
XR glasses.
Glasses on
what's
So I
glasses
can
on
walk
glasses.
wherever I want. I can walk around the house and I've got a big telly in front of
What
me.
can
spectacular.
you see?
You
What
see?
can you see?
I can see you. I can see you, Kobe, there
I don't
on
have
my
a
screen.
camera. Everybody else
You're not
can
on
got it.
camera.
Yeah,
But
Kobe doesn't have a camera. Come on, Kobe. You got all you can control the universe, but you can't get a camera.
yeah,
I
it's a great
know, I
idea.
know. I'm waiting for you to buy me one.
Don't fall,
All
Mom
right.
Week. Don't trip, Mom Week.
Yeah, what's the model? What model? What do you got? What are you wearing there?
This one. I've got it. It's the X-Rail one, the new one. I had it somewhere with me somewhere. I kept the box somewhere. It's must
Don't
be.
walk into anything. It's
Yeah, I'm
gonna walk
walking.
into a
No, no,
wall.
I can
Oh,
see
you see?
everything
Okay, good.
ambient about me, but I still have the big screen in front of me as well. So it's the X-Rail one, it's the new one. Get
It
these.
kind of
They're
reminds me of
amazing.
like, was it
Wait,
Ray
those
Charles
glasses
a
are
little
supposed to
bit?
be like that?
Sorry?
Those glasses are supposed to be like that?
Yeah, so basically I can see everything ambient around me, but I also see in the middle is a big screen.
Oh, I think I missed
So
that part. So they're actually doing something. I thought you were doing it as a joke.
no, it's not so it's real. I'm real.
So
My
you're
fault.
on Zoom right now on the
My
glass.
fault. My
Yes, I'm on
fault.
Zoom. I'm on Zoom
I
walking
thought you
around.
just shared it. Okay.
Yes.
Don't try to drive, Mom Week. Don't do that.
And have you guys
There we
seen
go.
this avatar that the guys at Kaltura made for me? Let me show you guys this. So they made me an avatar of all. It's basically an amalgamation, apparently, of all the presentations I've done, and you can talk to it. Let's see what it's. Let's see what it says here. Getting ready. Should have.
Hey, Rube's avatar here. AI, not the real Rube. What's on your mind? Ship something, the Agentics Foundation, or preparing for a consulting session?
What's going to make me the most amount of money?
This isn't about quick riches, it's about building something valuable. What if you could create something?
I want money.
I hear you. Hey, what if you could save 80% on legal fees or have one person do the work of 10? What skills do you have that could be turned into an AI-powered service?
You're the worst. You're actually going to replace people? Like that's not what we exist for.
This isn't about replacing people, it's about empowering them. What if AI could be a unit of empowerment, helping people achieve 10 times the productivity? How can we shape the tools and the safety principles together?
What's the
Did you
Agentics
smile?
Foundation?
The Agentics Foundation is all about PACT, proactive, autonomous, collaborative, and targeted AI systems. Would you like to
That's pretty
learn more
cool.
about the Agentics Foundation community at
Yeah,
agentics.org?
what are some of my best projects?
This isn't about past glories, it's about future.
Shut up.
Smile more.
This,
He needs to smile.
yeah, he needs to look at the camera and he needs to be a little nicer. But
You need to say he did it.
yeah, well, thank you, Kaltura, by the way. That was awesome. So
That's
basically,
pretty neat.
they trained an avatar on like 2.5 years of all the video that I've done on these sessions. So it knows basically everything I've talked about for 2 years, and it created a sort of avatar version of me based on that.
Hey, can I get that? Then you have a camera.
Yeah, you're gonna be me. Can you? And I think Peter said I looked younger. Thanks for that, Peter. I appreciate that. Matt, what's happening?
Oh, not much. I just wanted to, I guess, just chime in. We changed the air in the room a little bit, but I think I'll just add last point, hopefully to Cornelius' point, and just so when I was 12 years old, my pop told me I ran to him. I had this idea about something. I can't remember what it was. I ran to him. I was like, "Hey, Pop, let's do this thing." And his response to me was, "Ideas are like assholes. Everybody's got one." And that just stopped me in
I
my
think it's
tracks.
excuses.
I was like, "What?" I did. It hit me like a ton of bricks at that moment, right? And I still remember to this day. And I actually talked to him about it about a year ago. But the message to me, I didn't understand it at the time, but now what he was sharing with me is that, okay, you have this idea, now what next, right? And I didn't get it at that moment. And see what I see with Cornelius and what taking Cornelius out of it, what I see the beauty of having the access to what we're talking about is that, yeah, I can go and figure out high level what to do with chips, how to even potentially go with chips and go in that direction to design hardware. And then what I see from what Ruve you said is that now figure out how do you apply it? How do you validate it? How do you, because that's, we're all exploring the art of the possible, right? And
Yeah.
so now how do you take that art of the possible and go the next steps and be, yeah, somewhat crazy, right? Because not, it's been said by Dave multiple times, the things that we talk about on this call, in this room, so to speak, is far in advance than other people that are talking about. So some people aren't going to connect to what we talk about. In fact, the software uh, platform that the gentleman shared earlier is kind of not same as Claude Flow and what Ruve's already done. We've already done some of these things that people bring into the room. So all I'm saying, Cornelius, all I'm
No,
saying,
hold on.
yeah,
Hold on.
yeah, yeah. I'm not finished. I'm not finished. Just let me finish for
I
a
will
moment.
address
Just
that.
let me
Okay.
finish. So, and this is not just to you. It's when I saw you what you did, I'm excited about it. But also, in addition to the excitement, I want to know how to think the art of the possible, anything, robotics. Rue mentioned robotics earlier in this week. I want to do robotics. I know nothing about it. Now I can unlock and start experimenting. But next part, what I've heard from Rue is like, okay, how do you validate? And that's
So
what
hold on.
I don't have the
Hold on,
complete
brother.
answers to that, right?
Let me just break it down to
So
you real quick, right?
that's
Because
my
you
piece. Yeah.
you remember that from 40 something years ago, that one moment, right? And then what I'm
Yeah.
trying to tell you is the art to get to super intelligence is exactly what you described in that moment, right? My mother raised me in that moment was, what is your idea? Explore it. Go explore it. Explore whatever idea you have, right? And that's the difference. That whenever I went up to my mother, was like, I have an idea. She said, what tell me more about it. So I learned the concept of meta thinking, right? What you're explaining here to me, and you're saying again, like, rule have this, now I have this rule. You're learning dogmatic principles, right? And so how do you get to super intelligence is you have to break all of the chains of dogma, because you have to say to yourself, what everyone thinks, you can't create what is not possible by thinking that it's not possible. You have to look at all of the,
I'm
you
not
have to
saying
say,
that.
let me finish
Yeah.
what I'm saying.
I'm
So
not
the
saying that.
idea, what I'm trying to say is that the idea that holds you back, that holds anyone back from hitting the super intelligence level, is that practicality that you're trying to put into play. Fuck it. Go try it. I walk outside in -3-degree weather, right? Everyone would tell me that practically that's going to get you sick. But mentally, I'm the kind of motherfucker that doesn't believe that what everyone else thinks is real is real. And in order for you to get to super intelligence, you have to break that mold. And so what I'm trying to tell you is that what I am telling you from the place that I'm telling you that every human being can get to is that in order for you to get there, the idea that there is a right or wrong has to get out of your fucking mind. There is nothing. There is nothing. And there is nothing in any, there's no rules. Explore. Go do whatever the fuck you
I
want.
think the
Try it and
unfortunate
learn.
part, Cornelius, is that you don't realize we agree with you, and we agree with you. All
No,
I'm saying, both sides. Right
I'm
now,
saying,
you're coming at me
I don't
as
agree.
the 12-year-old
I'm
person
saying
that
you
I
don't,
was. We
I'm
agree
saying
with
you
you.
can't,
I agree
look,
with you,
I'm
but
saying you can't agree with me if you see that there's both sides, because I'm saying to you that the any side that tells you that pragmatism should stop you from fucking exploring, throw that shit the fuck out. Whatever you think is possible, go fucking try it. That's
that's
what I'm
what I'm
saying.
I
No,
think that's our
no,
I think that's our
don't let no
mantra.
practicality comes into play. If you want to, any problem that comes up in the future,
sorry,
build a
guys.
fucking solution to solve it.
I was trying to
Yeah.
change the air a little bit, but I just wanted to say that. But sorry about that.
There,
Yeah, yeah.
there's an interesting, if you look sort of deep inside some of the things that I'm building over the last couple of years, you'll notice that I've got some Latin in there. And I sort of embed this in my models and in my prompts, and it's called Cogdo Creo Cort or Cort. Sorry, my brain's not quite moving it right. Cognito Creo codex. And what that loosely translates to from Latin is I think, I create, I build, right? And that is kind of my motto. It underpins everything that I want to do. It means that I have no constraints in my ability to create anything that I can think. If I can think it, I can create it, is the sort of idea behind it. Now, the manifestation of that, if I can think it, I can create it, anything I can create, I can build, is actually in the name of the cognitum chip that we came up with, because cognitum is the manifestation of that. And it's the ability to think, it's the ability to understand, it's the ability to take that and build in whatever you want with it. So I know I'm sharing a little bit of the sort of the nerdy whatever underside of the stuff that I build,
Wow,
but that
beanie
that's
beanie
a that's a
beachy.
yeah, it's a critical sort of part of the equation. And I think that most of the people that at least I interact with, and there tends to be a kind of feedback loop in the discussions I have, because when you reach out to me or whatever, we work together, we kind of are, you're already drinking the same Kool-Aid. But the underlying theme, I think, of everyone I sort of associate with recently is the infinite is possible. We can move beyond any limitations we set on ourselves. And that is 100% true. And we show that every week on these calls. Like, I just dreamt up something on a whim on a Tuesday night and built it, and it works. Don't ask me how, it just does. Right. And that's amazing. And there's no better feeling than the moment you created something and suddenly you're like, oh my God, it works. Right. I'm celebrating around my office by myself in the middle of the night saying, I did it. This is the best thing ever. Like that dopamine hit that you get. That's what I do. That's why I do it. I think we got is that Lorraine I see?
Yeah, it's me. Great talk today. We've strangely gone into more philosophical speaking today than our usual technical one. But it sort of fits in with something I wrote about on LinkedIn this week, which was 5 shifts that matter. Basically, the whole position was that knowledge isn't the gateway anymore. So what I basically said was there were 5 shifts: authority, acceptability, coordination, judgment, and supervising. And so now it's more not creating the work, and it's more deciding what, your taste and your judgment in terms of what to do. So in terms of what Cornelius was saying, in terms of like building this system, that's not what the bottleneck is anymore. Is it the right system that you should be building? And also to go back on Reeve, you posted something about this WASM work that you did and building on Edge and your LinkedIn post. And I've been thinking, so one of the things I've been trying to push you towards in these sessions is many years ago, the founder of Vercel, I used to follow him before he started Vercel, you see, and he did Socket.io, so that's what he was famous for. And I've been thinking, when you have such talent as you do you really want to be doing what you're doing? Because I follow this guy so closely, right? I see so much potential for you. So sometimes when you think, like when I say, single point, it's just because like I see like even like a grander vision, which maybe you are working towards it and not sharing it with us. So that's just my other aside. And I thought maybe part of what you were talking about with this on edge and sort of WASM sort of thing could be potentially a gateway towards that. And to loop us back slightly, there was this thing about Tailwind, which I don't know if people saw in the news, making 75% of their workforce, albeit a very small team, redundant. And it really hit me. And it hit me because I thought, isn't that part of what we do when we work in open source? Is that we create content for other people to monetize, right? Because what we're so passionate about sharing the knowledge that sometimes we also leave ourselves exposed. So it's something that we need to think about. So it's just different sorts of things I wanted us to think about.
You're right. As a techno socialist, that's not the path to being a billionaire. everyone always tells, it was like, you could be a billionaire. You had that idea before anyone else. You did this and they did it and whatever. I guess I'm not like hurting, but I have no interest in being a billionaire either. It's not really, that doesn't motivate me. It's not, and I find we are, we seem to correlate financial, success with some sort of metric on life success. That those two don't aren't bounded for me. I have no interest in being, Elon Musk or anything involving that. My goal is to do things that keep me interested, keep me excited, and building and sharing those things. And I love that. Now, I am starting a startup, and I've been sort of not so blatantly not sharing, what I'm doing here. This is a first of its kind agentic chip. I don't think anyone's ever done anything anywhere near this. There's no architectures that are even similar to this point. We'll be in the market here shortly to do these kind of on chip devices. I've got a substantial, and if this does really well, some startups do, some startups don't. You never really know. But if it does really well, if I can make the world a little bit better place because of it, I would be a happy guy. And financially speaking, who knows what'll happen, right? But at the end of the day, my downfall is, I guess, I'm a little bit anti-capitalist, and that's not the path to riches in a capitalistic world. But I'm happy. What else can you ask for? I don't know. Right. Vlad, you have a comment?
No, how about just completely changing topic by going back to the. I'm just going to ask the same question I asked like a few months ago because it hasn't been solved yet. So when you write an agentic code, how do you assess the quality of it? So like basically, if you have like a set of like two, like you have Claude Code or like you have set of prompts and everything, right? How do you know like the one output is better than the other?
So I've got a new approach. I was showing that
Okay.
actually yesterday in some of the work that I was doing in Cloudflow V3. So let me show you. It's called an ADR, and it is actually similar to what Colm was showing earlier. Conceptually, very similar actually. So if you go to this is my, hopefully I'm sharing the right screen. You guys can see my Cloudflow repo here, hopefully.
Yes.
Okay, so in the implementation folder, you're going to see a folder called ADRs. The ADRs, the Cloudflow V3 is a substantial undertaking. It's currently more than 265,000 lines of code, a complete rewrite of the V2 architecture. I'm using a modular form. No real code that existed in V2 exists in V3. V2 was 126,000 lines of code, not including libraries and other bullshit, but actual functioning system. So what this system is doing is, I got too much stuff open. All right. All right. So, I got it decided to do double view here. All right. Let's give that one more go. Okay. So what this does is gives me a bounded structure to work within. So it bounds it within the structure of the deliverables. So it uses the Spark methodology and the spec-driven development, but then it gives it something I can measure against. So when you look down here, you see DDD domains. These are the sort of domains that the system knows to work within. So these are domain-driven design structure. So these domains allow it to understand not just broadly, but specifically what it needs to work within very tight bounded deliverables. In this case, decisions and structure that it needs to understand. Very similar in what Colm was showing earlier. Now, the key difference here is I'm providing a very strict sort of rule and proxy system that basically takes those and proxies them before it makes the request to the LLM.
All right.
So if the LLM decides that it's going to go and do something that I've already built in another module somewhere else, the vector memory stored says, oh, hang on a second, there's something similar that already exists. If the security, for example, breaks, in this case, you see that I've CVE3 and I've got memories. So background workers are being kicked off every time something happens in the system. There's background processes that then check security, the domains, the specifications, and then there's an inter-agent communication that happens as a secondary message bus behind the scenes that keep the agents working in the correct domains and structure that they need to work within. That optimizes the code, because what I'm really trying to do in the code base is not verbosity. I don't actually want 265,000 lines of code. I actually want the minimum amount of code possible at the fastest possible operations. So 265,000 lines of code actually probably represents an order or two of magnitude more code that would have probably been built if I had done this last June.
Right. But I mean, what I'm looking at, I guess, kind of numbers. So you got this. So for example, even you run this whole thing, right? You run your agents twice. They will gonna produce different code bases because like LLMs naturally like they kind of stochastic, right? How do you know which one of the two is better?
So that the deterministic system that underpins it. Now to test that, what I did is I do a variety of different sort of development patterns, and then I do that over and over and over again, and I check for any drift. Now, when I detect drift in the system, I then basically tell the sort of learned model that you can't drift. You have to stay within strict boundaries. Those boundaries are defined in an interim memory system that I've trained or pre-trained specifically for the purposes of Claude Code in this case. So it knows how to write effective systems, and then it's capable of monitoring the drift if it reaches a point where it's making suggestions for things that sit outside of the bounds of how it needs to build.
Are you doing them all async, or do you have them not async?
It's all async.
But
so
sometimes drift is good, and I think you pointed out that hallucinations are not always bad. Like so, it might be drifting to something better. Like
it's drift. Drift is good for exploration. It's good for specification. It's good for discovery. It's good for in analytics. It's terrible for explicit implementation.
And by the way, if you haven't upgraded Claude Code, it's like one version or two versions ago, all your sub agents count cache in the total tokens because I was getting 1 million outputs. I don't know if anybody else had the problem, but it was like scaring me. If you upgrade to the new version, it stopped. It was doing it with Claude Flow too, by the way, like for a period of time.
I've got and by the way, the new Claude Flow, which I'm getting pretty close to, and if you want to try it, but there's that will I've got a reduction system for the amount of requests, and you can really crank that up. So if you want to lower your
too, which was good.
Yeah, it's way simpler. It's way more optimized. And the last thing I'm going to mention, you've got the ability now to export your learned pre-training and models. So if I want to export like everything that I've learned in a certain repo or a particular development methodology that I've devised, I can export that, and you can import that into other projects. And you can also import directly from other projects that you have running. So if you've got Claude Flow running in 3 different repos, you can amalgamate all 3 repos and take all the learnings from each of those repos and then share it with the other repos, as well as compute resources from those repos. So if you're running this on multiple code instances or machines or whatnot, those machines can share the compute capacity amongst all those machines and form an ad hoc sort of capacity sharing agent system. So you can spawn federated learning agents that by the thousands or potentially millions that work in the background.
Okay.
It's craziness. It's craziness.
And Dragon is here. I guess he was working. I haven't actually looked at the recent work, so I guess he could probably chime in.
I have a question, Rue, because I was trying to reconstruct Claude Flow just for fun. You know me.
Of course.
I was having trouble with the async stuff, so I had to like async in parallel or whatever. I had to actually, because I have a reviewer and a tester and a documenter, I had to remove it from doing all async because I kept having them kind of run at the same time. Yeah, just the end, because I wanted to make sure they all ended before the next one kicked off.
It's super alpha, but send me over your issue.
Not what you did. Yours works. I was trying to figure out how you made it work because I was trying to like rebuild. I had your new Claude Flow, but I was trying to like build my own. I was trying to like make my own just for fun, just like to see if I get it to work, and I couldn't. That was the part I couldn't.
There's two parts. There's two parts that makes it work. One, I'm using the quick UDP algorithm, or it basically it's eventual consistency. So what that assumes is the agents aren't always available for whatever reason, but eventually they will be, and there's no handshake, so it's way faster. That creates a secondary sort of communication network that underpins the internet itself, that uses the
Okay.
UDP protocol versus the traditional
But is it a
TCP.
prompt? But is it a prompt to the agent? Because the agents have their own
No,
context, so they're
it's
like,
it's the WASM. So there's a WASM that handles that
so
particular
the agents
element.
that you're spawning don't get the Claude MD file, because all, like, if you run an async, they
No,
all get the Claude
don't need
MD
it.
with tokens. Okay.
No, I
Well,
don't.
you
I don't need
it.
it.
You don't need it by default, because
No, so
you're having Claude code launch them right in it.
Think of the workers are independent agents that operate completely separately from Claude, and they're
by default,
tasked.
Claude forces you to put the Claude MD file in. You can't say not to do it. Like it forces
I'm not
12,000
using
tokens.
I'm not using Claude for those workers.
But there aren't. Okay, so maybe I'm wrong about this, but I thought that they were. So I was originally trying to launch them through the agent SDK, but then I switched because I was trying to like mimic the Claude Flow, and I was having actually Claude code launch them, in as backgrounds, which does the async, but
Yeah,
it forces that Claude MD file into every agent because they have their own context window and they have to have it.
Yeah, so I think you're thinking that these workers are basically Claude Code sub processes when they're not. They're completely separate.
I think that is what I was thinking and trying.
Yeah, so the key here is remember that so if you make the distinction, at least in my nomenclature, between an agent and a worker, in my mind, I see a worker like, these robots floating around trying to fix things in the background or whatever. They're very task specific, and they don't need the sort of LLM. Yeah, they don't need the LLM to guide them. They're being guided specifically based on the attention mechanisms that allow them to focus on the problems they're trying to solve. And then when they're done, they can communicate that with language back to me and tell me what it did. But all the intercommunication and operations of those agents are essentially just various forms of mathematical structures, vector, graph,
I'll just
and
show
attention.
you later too, because I know what you're saying. I want to show you what I'm talking about, because I spent I spent way too much time trying to figure out how to do it. I almost gave up trying to get it right. You got it right. I just was trying to figure out how it worked.
Don't give up, man.
Yeah.
Stay on.
I'm not giving up. I don't give up.
And Stu, you've been hacking away on some of this stuff too, right?
Yeah. I was on it till 3 a.m. last night. I've got 3 different apps on my screen right now building out with it, and it's beautiful. And literally just asking it, hi, I know you built this app using Cloudflow 2. Here's Cloudflow 3. What do you think? Evaluate it. What would you do? And it's rolling out all kinds of stuff, including
there's a new, by the way, anyone that's tried the previous alpha, I pushed out a new update this morning. There's a better init. The init now will do the pre-training and neural optimization as part of the sort of initialization. And what it does is it actually looks if you've already had Cloudflow version 2 running, and then it does an analysis of the sort of memory system that existed in Flow v2, then trains and optimizes based on that as part of the init. So it's a significant improvement over the one from yesterday.
Oh, that's good. Okay. Listen, whatever it is, the stuff is great. One confusion, quick question I had for you, Rube, is I used to implement Claude Code v2 in a repo. Should I be doing it? And this one said, take Claude Flow v3, just roll it globally. It's fine, because otherwise I was literally burning through 2 Max accounts overnight.
Yeah.
I had to go back and forth 3 different times.
I'm trying to fix.
Had multiple things running and
ask. I'm not sure how aggressive I need to be in sort of infusing this tool into your Claude Code environment. But if you ask the system to do 2 things: 1, review the hook system, and 2, ask it to optimize the system to reduce the amount of tokens used within sort of Claude Code.
I figured that out at 2:15.
Okay, good. So the trick of that actually isn't Claude Flow. It's Agentic Flow. Agentic Flow has the proxy system in it. Although that's integrated in the Claude Flow, I haven't made it explicitly available.
Doesn't the Agentic Flow do it all though? Because the
Yes,
Claude Flow is
Agentic-
just Claude Flow is just an orchestrator in and
Yeah.
of itself. It doesn't actually deploy or at least
Agentic
that's
Flow
what
is
I
where
found out.
Agentic Flow is basically me packaging up Root Vector into something that's
Yeah.
more accessible. And Root Vector is like the edge of the spear. It's all the crazy and it's all the stuff that I think I'm the master of the universe at 3 o'clock in the morning. But I needed to make that something that's like understandable to make me not sound like a crazy lunatic. So Agentic Flow is more productized. It's not crazy, and Claude Flow has hundreds of thousands of downloads and users. So I need to make that even. Yeah, I need to make that most focused and the least crazy. So I'm not going into like rabbit holes of min cut and stuff that people are like, what the hell is this guy talking about? If you like crazy, Root Vector. If you want quick, easy, usable, it'll be Claude Flow and Agentic Flow.
Will Claude Flow automatically use the resources it needs, or do we need to call?
Yes.
Okay, so we don't need
the init now will automatically review your repo. And I've got hooks. In the most important folder you're going to want to look at, and when you install it, I'm going to show you guys something quickly here, is in the helper folder. So when you initialize the system, you get all these agents, but the real interesting stuff that you're going to want to look at is actually in these, because I can't activate everything for you guys because different environments require different things. But sorry.
I second that. Hooks are very important.
Am I sharing the wrong screen again? One sec.
No, you got it. The helper screen.
Okay, sorry. Yeah, there we go. Okay, one sec. Okay, so right here, what you're seeing, so for example, here's a DDD tracker. So this tracks domain-driven design. So these are hooks. Now I did them as SH, but I've also included some JavaScript ones that make it look. This is the repo that I'm building it in. If you were to actually go to a repo that exists, here, let me show you one that exists independently. You have slightly different stuff. So this one here, we've got wrong one.
And the guy who's burning through his tokens too. You can set hooks so that it stops with tokens.
Yeah, that's exactly what you're gonna do. Perfect.
You can
Exactly.
put that in, and so it'll kill it or it'll ask you.
Yeah, so you've got guidance hooks. So these hooks are fired on when different things happen in the system. If you edit, if you update, if you do whatever. So here's a learning hook, right? So this is telling it how to interact with the learning system. Runs the Sona micro LoRa at certain points. Or and then I've got a JavaScript version. If you're on Windows, might want to run that.
You want to tell them which ones come by default, because I know you're saying that you built custom ones, and you're promoting, which I am too. You should put custom hooks in because they'll still work with Claude Flow, meaning you can add hooks that do things with Claude Flow without like destroying Claude Flow to whatever you're doing that benefits you.
These are the hooks. So these are the hooks you're getting. You see them here. You got you've got various matcher types when it does a task, or post after it's done, and that's calling these hooks. Now, you've also got a status line. The status line allows you to see what those hooks are doing. So I've given you a sort of running start here. And to be honest, Colby was the inspiration for this. Thank you, Colby.
I have like 10 lines.
Yeah, so Colby's has got the craziest ones I've ever seen. But I didn't want to do 10. But so you can basically point the system at the status line, either SH or this, and tell it to customize it. And that
mine tells me what my agents
are
actually doing.
Show us your status line. Colby's got like.
Okay, hold on. Share screen here. The Mac attack. What do I? Oh yeah.
It's an interesting question, Rude. If we had a custom status line when we loaded in Claude Flow 3, shouldn't it have taken over that status line? Because it didn't. It did on one of my repos. It didn't on another. I wasn't quite sure why.
I fixed the init this morning. Yeah, it was an error. It was in the error in the init that I had yesterday. Yeah,
might be a couple lines that are taken down because I just zoomed in. But yeah, I have like what's going on in my, like, at least I think is AGI, my agent. I have like trajectory done, how many vectors, crystals, the brain, the nodes, the edges in this project, more crystals that do other things I'm not going to explain. Memory packs, these are reusable code snippets. Like I have an immune system. That's what that little DNA thing is right here. This 112
What does
memory,
the
and then I
immune
have
system do?
it like I build everything kind of like the real world. So it attacks things, it finds errors, it'll stop something from doing something bad. And similar to how Rue does things, so in my system, I store every single conversation, every single thing I'm doing, everything's an episode and checkpoints, and everything's task based in a task system that I call Fox Tasks. So like everything is connected. When I make documentation, the documentation connects to an episode, which connects to a checkpoint, which also connects to files. So anytime my agents want to look something up, if they look up a document, they can see every file, they can see the episode, they can see the checkpoint, they can look in the database to see what happened in that episode if they need to. So some of this stuff is like, for me, some of it is, I mean, like it tells me too, like my agent's excited. These three little things are kind of like latitude, longitude for how happy the agent is. And then it tells me if like my database is on, what's working, the concurrent requests, the skills that I have, and the principles. The principles is the constitution that I have for the AI, because I don't dictate where my main AI goes. It can just traverse my code and change things and make work trees and do whatever it wants. I can stop some of those things, but I have it fixing errors and stuff. So if there's an error in my code, it's just traversing all day through my code, even right now. So
that's wild. And do you also do you tell it to optimize how many swarms it's running based on capacity of the machine it's running on?
Well, that's why I was smashing my head asking Rue all those questions, because yes, I love Claude Flow, but I like to rebuild things, as he'll tell you, and I like stuff. So I could have just installed it and used it, but of course I wanted to try to build my own, and I have like 15 systems that I tried to build, but I also didn't realize there was a glitch in Claude Code. I was like spawning like 6 agents, and each one was going to like 750,000 tokens in a second.
That's
and
what I was doing.
that was like 4 days wasted until I figured that out. And then once I upgraded it, that went away. Yeah, I have a whole like flow system that goes through, even if I'm using Claude Flow, that breaks down I can type anything I want in, and then the AI basically takes what I have, looks at the context of the conversation, breaks that up, and decides if it's a parent task or a subtask, and looks at my tasks and kind of determines what it's going to tell the agents to do. And I actually took, I'm not sure who made it in this group, but somebody made a Claude Flow agent repo that had 610 agents and all the background on it. And I was using that at the beginning.
Oh,
because this really,
Kobe,
yeah.
I'm actually, Cloudflow V3 is going to have an IPFS based plugin and like model sharing system. So you'll be able to publish your plugins. The plugin system, which I'll show another day, extends the entire system without modifying the core. So you can build all kinds of crazy stuff, sort of. And then if you want to share it, you can then publish it to a central repo, and it exists on the IPFS blockchain for free forever.
Nice. Well, anyways, I looked back at your 3, and I actually, instead of using because I had it choosing the agents out of 200 agents, I actually scaled that back and went towards like what you did, which you're doing it based off of like a new feature is 5 agents, 3 is just a regular thing. So I kind of scaled back, and I found that worked a lot better. I still do have types and like hybrids of what I'm doing, but also I'm using Augment in mine too, which improves. So I have something called FDAG and crystals where I'm predicting files that I'm going to be editing. So I do kind of all of that. And then I do a super prompt into a prompt enhancer, and it splits and partitions the agents that I send it with the predicted stuff. And I get like the most miraculous prompts in the entire world that you could ever want. Rue can tell you, I showed him how I got those prompts, but now I have it doing it for each agent in one call. And it just is phenomenal.
Kobe,
it works really, but it's a 60-second lag but it's a server that I'm running. It's called Augment. It's right here. So Augment's like nothing new. It's similar to like like Claude Code, any of this stuff, right? But this is it. Do I have the wrong thing? So I'm gonna hit start indexing because I want it to load up so you guys can see it. I had another thing in here in the workspace, so it's I might have
What are the
actually closed
six? What are the 6 skills you got? Are they cloud skills?
hold on one second. Let me just reload the window so you guys can see the augment thing. I had another repo in here. I want you guys to see what this is. But I think this is important. I think everybody should be using this. So you could do a prompt like, "Hey, I want to add, or I want to improve. I'm just gonna pick something. My Claude hooks or something. Just whatever you want to put in. So Augment does index your whole system, and you can choose what model you want. But you just hit this little star button. Now I'm doing it automatically on the back end, but I used to use it just like this, where I type anything I want in here, and it just turns the prompts into like the most beautiful thing. And this is kind of a basic one, but it includes files, everything that you'd ever want, like, to do in here. I could probably
How
do
do
a
we
better
get
one.
that? That's very
You
cool.
literally just search. It's Augment. It's just like downloading Codex or Claude Code. You can just search it. I don't
I've
really use
pasted
it
the
to
link.
code.
I've pasted the link, guys, into the chat.
Yeah,
Oh, awesome.
Yeah.
Thank you.
use the extension. The VS Code extensions. It's the quickest
Yeah,
and
like you
easiest way to
can
get
say
it.
like anything, like build me security features inside the code base, and it just, these are kind of dumb ones, but it will find everything that you want. Now, I found that predicting the files and handing it the agents and doing different things, I get a lot better of responses, and then I'm parsing it through a process outside of this, so I don't have to manually do it. But you can see like just that basic. I mean, look at this is actually a better one. See, like I just wrote. Build a security thing. Design and implement a comprehensive security system for the Foxflow code base with following components: authentication, like add role, all this stuff. And it's
All right, guys.
using.
I apologize. We gotta wrap up. I gotta jump
Okay.
here. But
Sorry, I like talking.
no worries, no worries. The augment stuff is amazing. You've totally converted me on that as well. It's a quick and easy way, and because it understands your code base, it kind of magically gives you the spec in the right way. All right, guys, this has been an amazing another week here. Thanks for all the input and lively discussions. That's it for me this week. We do calls. There's somewhere or another there's an Agentics call every day of the week. This particular Zoom is now a static Zoom. That means you can take this Zoom, you can add it to your weekly calendar, and we'll use the same Zoom call every week going forward. And we'll update and Matt, we get to update the website to include this particular Zoom if we can.
Hey, yeah, Rob, actually today I couldn't find the Zoom on your agentic AI site. Is it gone? So I found it through LinkedIn, but
yeah, we're gonna update. Matt and I will update the website here momentarily with this particular
okay.
Zoom introduction. And yeah, that's it. That's it for this week. Thanks everyone. Thanks. I love seeing this stuff. Keep an eye out. Eventually, Claude Flow will become the primary. I'll push it out probably the next day or so. A little more bug testing I need to do, but I'm feeling pretty confident. I've been using it on a bunch of different projects, and I've already had several thousand downloads of it, so not too many complaints. Yeah. All right. Thanks, everyone.
If you got time, hit me up later. I want to show you the thing I sent you.
By the way, we do hang out on the Discord channel, discord.agentics.org. If you guys want to show off what you're building, that's the place to do it. All right.
Can you throw that in the link?
Appreciate it.
Yeah, I'll throw it in real quick.
Appreciate
Discord.
It, thanks, guys, for listening to me rant.
This looks really cool. Thank you, man. And thanks for the tip on Augmented.
Yeah. It's awesome. Check it out.
All right.
Thanks, awesome. Everyone. Good weekend.
Hero AI, right? Is that what you're using, Colby? Looks amazing.
I was saying Augment, but you're talking about for visuals. Yeah, Hero. It's called Hero Chat. Hero. I think it's Hero
UI
Chat.
or something like that.
Yeah.
All right.
Yeah.